Well, welcome everybody. It's been a little while since we've done a video. Today I want to talk about timers and counters. You'll use this as part of your instruction set. So far you know about the examine if open. You've used the examine if close and the output energize. So just like the output energize is it's an output instruction, you'll find and learn that a timer is an output instruction and the counter is also an output instruction. So remember, the output instructions, when you put them into your simulation software, they snap to the right. So you'll see that when you use the timer instruction or the counter instruction, they too snap to the right. So what I have here is a document. I want you to be familiar with the three basic type of timers. There's the on delay timers, the off delay timer, and then the retentive timer. The word retentive means it retains the time, so that if say the time is interrupted, it'll pick up where it left off. So TON, TOF, RTO. So you want to be familiar with those. These are the most common types of timer, and by far the most common timer is the on delay timer. So you'll work with that when you go through the lab. Here's a symbol. You have access to these outputs here. These are defined over here, these bit definitions. So EN, DN, you have the enable, the done, and the TT. You can reference that. It's actually a bit that lives in the data table, so you don't have a physical output like you do here. So if you want to use a TT, that stands for timer is timing bit. So what happens, the enable bit, say you have an instruction over here. If you have a wrong and it's conditional, meaning you have an instruction like an examine if close, you have that mapped to a switch. You close the switch, the examine if close command instruction is true, then this enable will go high. Now as long as this enable is high, the timer's timing bit, it's a high until you reach the end of the time, and then the timer if timing bit will stop and this done bit will at that point go high. So the TT right here, the TT and the DN, they toggle. You can't, if this is a 1, this is a 0, if this is a 0, this is a 1. The timer, the TT bit, timer's timing bit, only is a high. It's only a 1 when the actual count of the timer is going on. When you reach the end of that time, then that bit goes low and the done bit goes high. So you can use either one of those. You know that switches and coils are represented by a single bit in the input image table. Well, timers and counters are much more complex devices, physical devices, and so if we make a virtual timer or a virtual counter, you would expect it to be more complex also. And so instead of being represented by one bit, it actually takes three words of memory. Now remember, a word for us is 16 bits. So it takes 3 words of memory. The first word is called the control word. Remember, we start counting with 0. First word is the control word, it's a status word, and the second status word. Now, in the control word, the first 0 through 8 bits, you don't have any access over those. You're interested in what's defined here, the enable, the TT bit, and the done bit. Those are the ones you have access to. The values over here are pretty important. So when you guys go through the lab, make sure you're familiar with these. The timer address, well, without that you can't really do anything. So the address, the timer address, it starts down here with the T. For your simulation software, it'll be T4, and then the last thing is the timer number. It says 0 through 99, but I'm not sure your simulation software will allow you to have that many. But in theory, in the actual Slick 500 PLC, you can have many timers. You can have up to 1,000. So the timer address, the preset time duration, and the accumulated elapsed time, I think those are self-explanatory. The time base. Now, that time base, you can think of that as the timer resolution. The timer resolution. On your simulation software, the time base is set to 0.1. On the actual PLC, there's usually a switch where you can set the resolution to, say, 1 second, to 0.1 second to maybe 0.01 second. So it's usually adjustable. But in your simulation software, it's 0.1. Now, the resolution is important to know because the way you set the time of the timer is by this little equation right here. So the time of the timer, when it will time out or when it will time on, depending on the type of timer you have, will equal the time base times the preset. So this example here, if you set the preset to 50, the time base is 0.1. 50 times 0.1 is 5 seconds. So this thing will time out or time on in 5 seconds. So you'll see that when you actually go through the tutorial for timers and counters, you'll see on the timer tutorial where that you use this and you'll become familiar with it. It's pretty simple. Down here, I'm not really concerned about any of the information down here. Probably look at this. When I talked about earlier, the enable being conditional, this is what I mean. You have a contact here, and opening that contact will stop the timer. Closing that contact will start the timer. Now, if you have a retentive timer, if you stop the timer, it'll stop at a particular time, and then when you make this run true again, it'll pick up where it left off. So hence the word retentive. Okay, so just kind of review this sheet, and if you have any questions, something's not clear, you can ask me about it. I'm pretty sure that when you guys go through the simulator and you do the tutorial on timers, it's pretty thorough, so I don't suspect that you'll have any questions or any problems. But if you do, let me know. So on the quiz, you want to remember timer composed of 3 16-bit words. You don't have to name the words, but just know it's way more complicated than a particular individual contact coil or examinative open or examinative close instruction. So now I want to move to counters, and just like the timer, a counter too is composed of 3 16-bit words. Here are the 3 common types of counters. There's an up counter, there's a down counter, and there's an up down counter. And I think the names are pretty explanatory. And again, you will when you do the tutorial, you'll become very familiar with how they function and why they're named as they are. The up counter is by far the most common type of counter, PLC counter. This up-down counter, though, can you think of an application where you might use an up-down counter? Why would you want to be able to count up and count down? What would you use that for? Any idea? One example I think of when I think about the use of the up-down counter is like maybe for a parking garage. You want to count the cars going into the garage, and you want to count the cars leaving the garage, so you know whether to turn the garage's full light on, or if you wanted to, you could even display the number of parking spaces available. So any kind of application where you got to do some kind of calculation to keep track of something would be a candidate for the up-down counter. Here's some definitions here, depending on whether you have an up counter or a down counter. By the way, this up-down counter in some PLCs is an actual instruction all by itself. You have a up-down counter. In a lot of PLCs, you have to construct this out of an up counter and a down counter. So be aware of that. Be familiar with that. This first word here on this word 0, you have access to bit 10 through 15. Usually, depending on whether you have an up counter or a down counter, you'll access only bit 15, 14, or 13. The overflow, you have an underflow, and you have a update accumulator. You won't use that much at all, but if you need to know more about that, you can kind of dig into that on your own. The tutorial and the lab is going to focus on bits 13 through 15. So really that's it. There's not a whole lot to it. I can't really explain how to use this. You need to just do it. So your job is to, on the next lab, there's a nice tutorial there. Go through it, get familiar with these timers and counters, and then apply what you learned to the lab. and then we'll take it from there. So this is the shortest video you'll ever have. You guys have a great rest of the day, and I'll see you or talk to you soon. Thank you.